Welcome to the inaugural Modern Data Quality Summit, and we have no other than a celebrity in the data and analytics space, Chad Sanderson. Chad is wears many hats. He's prolific in sharing his views on social media, LinkedIn, especially. In fact, his followers have mushroomed very quickly to over 50,000 in a very short amount of time because a lot of things he writes are very forward-thinking. Chad, if I may say, provocative at times. Would you agree?
Yeah, I think provocative is a good it's a good way of describing it.
That is great. So without taking any more time, I would love to hear, Chad, can you please give us an introduction and what are you doing these days?
Yeah, thanks, Sanjeev, and great to be here. I'm Chad. I spent the last 10 years working in data. I started off as an analyst and a data scientist for a small company called Grill Grate in northern Georgia, and I eventually made my way to Microsoft, where I worked on the artificial intelligence platform, and we were handling large-scale machine learning jobs from all across the business. And then eventually I moved to a late-stage freight technology startup called Convoy that's currently on their Series E. So it's kind of hard to call them a startup at this point. And I started by owning the machine learning and experimentation platform teams, and then eventually moved to owning the entire data platform. And that included our infrastructure and technology around data quality. So these days, I'm running a community called Data Quality Camp. Data Quality Camp is a group of data professionals, data engineers, data developers of all kinds, data scientists that are focused on implementing data quality at scale. And the big gap that I saw in the market was that there's a lot of really great vendors that are talking about their particular slice of data quality, but there wasn't one place where people could look at data quality more heuristically end to end at different levels of maturity and have a community of like-minded people that they could ask questions about how to implement it the right way.
Last month, April 2023, I saw you last in person at Data Council Austin. I
Mm.
attended your meetup in the evening. It was super well attended. I was quite happy to see all these people that we've been communicating all descended onto your meetup. How big is DQ Camp community these days?
Yeah, these days it's about 5,000 people, just over 5,000 people. So I mean, we started in November of last year, and 5,000 people puts us at a roughly 1,000 new members every single month. So it's growing a lot, and hopefully we start doing some really exciting things and more events than just the one we threw in Austin.
I see. That is great. In fact, I want to ask you, what are the deliverables? What do you seek to do in DQ Camp? But before I even go and ask you about what are the goals of DQ Camp, why did you pick the topic of data quality? You wear many hats. You've been known for propagating the whole concept of data contracts. Why data quality?
I felt that data quality was one of the areas in data engineering that it wasn't exactly clear from what I had been reading online where to start. And almost every data professional that I talked to was really struggling with data quality pretty significantly. So everybody has the pain point. There wasn't really a great place to start. And there also wasn't a great set of steps on what to do at what point when that wasn't being influenced by a vendor in the space. And I have nothing against vendors, like truly. In fact, I think that vendors put out some amazing content, and these are usually people who are also hyper focused on solving a problem. But I think that there was a need to have a vendor agnostic space where professionals who had either solved the problem, were in the process of solving the problem, or were about to solve the problem could collaborate. I thought there was many other areas of data engineering where that space already existed, or data science where that space already existed. But for data quality, I just seemed like a big gaping hole that I wanted to fill with a community.
This has been a constant enigma for me. Why is data quality always top of the mind? I mean, I know like without good quality data, there's nothing good that can come out of all our analytics. But why is this such a persistent problem? We've been talking about it for decades now.
Hmm. I think that it depends on the era in which you ask that question. I think there are different reasons why data quality has become it has still been an unsolved problem up until now. My personal opinion, and of course this is biased because I'm a huge advocate of data contracts and more specifically the problems that data contracts solve. My bias is that we have yet to develop a clear ownership model, starting from the source systems and ending at the destination systems where data is applied and used. The way that it works for many, and I would say most companies that exist in the modern data stack today is, data is pushed from these source systems, could be a Postgres table, could be something in MySQL, could be SAP, could be Salesforce. It's kind of dumped and then handed off to a data engineering team who then hands it off to an analyst or a data scientist. And when there's no real communication or ownership or acknowledgement that the data that I manage and maintain as an upstream provider is an API, ultimately things start to break down. And then consumers will take steps to protect themselves from those breakdowns, like writing filters on top of their already very, very long SQL queries, which makes the data even more complicated, which makes it hard for any person who comes after them to understand what this query actually refers to, which leads to duplication and on and on and on. I don't think that that was the same problem in 1995 or in 2000, but I do think that is the problem, the hurdle that we face today.
So one thing that I found interesting was you said it has been an unsolved problem up until now. So do you see that we now have a light at the end of the tunnel? How is the modern data quality being approached differently so we can now expect to have higher success?
So I would say that modern data quality, I don't know if it's being approached fundamentally different from a philosophical perspective. I think even if you went back to, the 80s, everybody would say the same things about what data quality, what should ideally happen with data quality. You should have a strong data model that's connected to some real world semantic value. You should have clear ownership. You should have some way of ensuring consistency and reliability and measuring all the metrics that you care about that are relevant to data quality and surfacing them to the right people. However, I think that prior to the last couple years, this has all been done entirely manually. It's by hand, it's process, it's governance committees, and these things are very unwieldy. And I think that engineers, especially, aka data source owners, tend to gravitate away from process rather than towards process. And as companies become more nimble and more agile, and the engineers are empowered to, become even more flexible than they already are, generally it sees them shirking off the process in favor of moving quickly and iteratively and following this like agile set of methodologies. The reason I think that that's changing, and at least I hope it's changing, is because there are now mechanisms for data governance and data quality to also follow this agile, iterative, piece by piece sort of framework that adds incremental value. I think that's the piece that has always been missing. Typically, these data quality initiatives are big blasts. It's like, let's go in and refactor our entire data warehouse, or let's apply 100 different governance policies on top of all of our data. I think that's the mentality that's starting to change a little bit, to move from that to actually there's a small amount of data that is important, our data products, so to speak. And if we implement systems, processes, and tools that make it easy to iterate over these thinner pipelines in an engineering oriented way, then we can actually achieve data quality. Maybe there's not any true way to achieve data quality, but you can certainly start incrementally working towards it.
I love this answer because I see this happening in other parts of the pipeline, even building what we call data products, and we'll talk more about data products. But I think the problem you're saying is that in the traditional scenario, if we have a data quality problem on a dashboard, let's say, so the consumer finds out, the consumer may be a CFO, and so the consumer is like a beta tester, so detects a problem, and then the problem is because of this lack of ownership and too many products making up the pipeline. There's no ownership, there's no single person to approach and say, go fix this. So that ownership, accountability, you said, is a problem. Also learning from software engineering principles like agility, lean, and even like version control, so you can do A/B testing. Maybe is that so we can test.
I think that's exactly right. Like what you described is, I would say, one of the biggest, if not the biggest problem today, right? Like you are always going to have data quality issues. Like that's you
Yeah.
can't fix that. In the same way, you're always going to have production bugs. So it's not a question of completely preventing any issue. The question is, if an issue happens, does it get resolved? Is someone willing to raise their hand and say, yes, this is my responsibility, and I choose, it is a part of my workload that I will fix this. I will fix it in a timely manner, and that involves being able to number one, um, prescribe these constraints.
Hmm.
Number two, to monitor for them. Number three, the ability to communicate back to a producer that they have happened, and number four, to solve them in an efficient way, and then signal to your consumers that the problem is fixed. I think if there is a simplistic way of doing this, of taking ownership in a way that is incentivized. So it's not just telling people, hey, I expect you to go and fix this, but it's actually built into the incentivization structure of the producer, whether that's an engineer, whether it's a business intelligence analyst sitting in the warehouse that might own a view. I think that is the critical piece, and that's the piece I think that is changing quite rapidly.
I love this answer. It's a very logical, very well thought out. That's great. As I'm listening to you, my mind is literally firing off neurons. It's like, oh, wait, constraints. Is that data contract? Monitor, is that data observability? So in the short amount of time, let me just ask you about data contracts. What is a data contract and how does it fit into this approach that you just laid out?
Well, the simplest way of thinking about data contracts is that it's like an API specification. But it's an API that is specifically designed for data. In the software engineering world, a API is, it does include schema, but if the semantics of if the underlying nature of the API changes, we would consider that to be backwards incompatible, right? It's breaking the contract with the consumer. For data, there are specific data-oriented constraints that need to exist, and those constraints are expressed through the contract. So the schema is certainly a part of that, and that includes, data types, not dropping certain columns, ensuring that column names don't change. But it also includes things like the values of certain columns. So if I have a tax identification number that needs to always be a 9-character string, that should be a part of the contract. You can include things like distributions of the data. So if I have a column that's, let's say I'm working for a hospital and the column is called patient height, I would always expect that to be a normal distribution. And if tomorrow the data is bimodal, it's probably not that the entire population of the United States has changed out from underneath me. It's more likely that there's some production bug, right? And
Yeah.
so there's many different types of constraints that you can describe, but in my opinion, all of these should be described within the contract itself. And the contract is a technology agnostic surface. And beneath that surface are monitors that map to the proper places of enforcement where each constraint needs to exist, shifted as far left towards the engineer as possible.
That is great. When you mentioned contract has a schema and the data types, length, like some constraints, this cannot be null value and things like that. So that also reminded me that another hot topic these days is semantic layers, because data consumers may not always understand what is the meaning of this column. What is the relationship between a semantic layer and a contract?
So the way that I think about contracts is that contracts really need to exist anytime there is a transformation step at any point in a data pipeline. So if there's a handoff from an application developer to a data engineer, to a data engineer to a BI engineer, at those three handoff points, there needs to be a contract, some set of expectations, a semantic interpretation of what the data actually means, and a set of constraints that are enforced ideally during CI/CD. The semantic layer to me is built on top of a set of contracted data, because what you have then is trustworthy entities or events that with clear documentation that you can then aggregate in meaningful ways and store in a single layer and then vend that data to any non-technical consumer in the company to access through, self-service analytics platforms. And therefore, I believe that these systems are very tightly linked together. However, I strongly think that a data contracting system has to come first. Otherwise, the semantic layer is being built on top of sand. It's going to be shifting, it will be changing. All the issues that I described before are not going to go away. And therefore, it is impossible to have a self-service semantic layer because ultimately the consumer is not going to be able to trust the data in front of them because the foundations are not trustworthy either.
That is great. So a lot of people are building semantic layers. What you're saying is that the semantic layer should be built on top of the data contract.
Yes.
And so if I have a scenario where I want to do some reporting on an operational data, which is coming from an ERP system that's SAP, and I want to compare it with historical data that's in a cloud data warehouse, then I'm going to have multiple contracts for SAP and Snowflake and a single semantic layer? Is that how it be?
Ideally, there should be a contract. Any transformation step that is useful to any data product should have its own contract. So if I have, let's say, a machine learning model and a training set that I have built within Snowflake, and maybe I'm aggregating data from 3 or 4 tables within Snowflake, and those tables themselves are pulling data from Fivetran on some cadence from a Postgres database. Maybe they're pulling it from Salesforce. Maybe they're pulling it from SAP. At every step where there is an owner of that data, a contract needs to exist.
So the contract is either data transformation layer, is it? Oh no.
It doesn't necessarily have to be transformation. It could just be handoff.
I see, a handoff too. I see, got it.
Right. So if I'm moving data from one point to another and someone else is they don't necessarily need to be transforming it. I suppose that they could. That might make it an easier way to understand. But if I'm a software engineer and I own a database and that data is I'm streaming it into a data lake. Whoever owns the data in that data lake, it could be a data engineer, it could be someone else. There needs to be a contract there. If from the data lake it's going to a table in Snowflake, there needs to be a contract there as well. If it's going from one table in Snowflake to another table in Snowflake, there should be a contract there. If maybe you're doing something with the data in a production system, like you're pushing it out to an S3 bucket, then there also needs to be a contract there.
How where are we in this journey? Are we like close to, like, practically, like, are the products now that are providing this? How do we go about it?
I think we're still very early, but all of the core technologies in order to build that system exist. At Convoy, we use pure open source products for this. We use the Kafka schema registry, which is not just limited to streaming. You can do backwards incompatibility checks against schema for anything that requires a schema. So it works for checks in the data warehouse if you're using dbt, and then it also works if you're using some streaming system as well. We use GitHub to store our contracts. The contracts were defined in YAML. And then we were using a variety of monitoring tools that are all publicly available. Great Expectations, DBT. There's a tool called YLogs, which is from the YLabs team that does monitoring in the stream. All of these things are open source, and we stitched them together, and we formed a pretty solid, robust data contracting system. I think the next phase of this is going to be the cultural elements. Is how do we start to unite our culture around taking ownership over data products upstream? What are the engineering best practices for managing data APIs? How do they differ from CRUD API, and how do we begin to factor that into our daily work? However, I think this is actually going to be evolving at a rapid pace. I think things like LLMs will significantly increase the velocity that teams care about this, because, as I'm sure you know, LLMs or any model is only as good as the data that feeds into it. And so if now you have a business making very significant decisions based on data that isn't high quality, it could be very, very bad. So I think the need for contracts is only going to increase, not decrease.
That is great. In fact, I was talking to some people about how they're using LLMs, like GPT-4, for instance. They're pointing it to their data, and GPT-4 can look at free-form text data, and it can very accurately pick out first name, last name, even infer gender, for instance, even infer the nationality by looking at the free-form text. They can say this is a Portuguese name, for instance. It can even tell this disambiguation of dates and say this is a birth date and this is the death date and things like that. So people are trying to use these LLMs. It's very interesting to see how where all this takes us.
Yeah, sorry, go ahead, please.
No, please, after you.
No, I was going to agree with you. I think LLMs are going to take us to a very interesting place.
Yeah.
The ultimate fear I have about LLMs as applied to the sort of broader underlying data ecosystem at most companies is that as you say, it is very good at making inferences based on some semantic attributes. What it is not good at, I think, is making inferences if that semantic information either doesn't exist or is just wrong. And if you've worked in sort of large scale, very messy data ecosystems, one of the things you figure out very, very quickly is, like, you can't trust that just because something is labeled a certain way, that any model, let alone any person, is going to necessarily interpret it that way. At Convoy, for example, we had 6 different definitions of shipment distance. Sometimes it represented the distance in miles, sometimes it was the distance in kilometers, sometimes it was the distance of in time, and sometimes it was the distance as expressed in whether or not it crossed state boundaries. And all of these were things, and they were used interchangeably, but they were titled the same thing. And I think the challenge is going to be, just because there's a number on a screen, does that number actually reflect the semantic context that these ChatGPT-esque models think that they do? And oftentimes, the worst part is that sometimes human beings get it wrong. So there might be a label that we put on the data, which is just simply incorrect. It actually doesn't represent what the data actually is. And this is extremely common at businesses of all sizes. So yeah, I think there needs to be some solutions for that before we really start to trust what these models are telling us.
This fascinating discussion. Another challenge that I hear from customers is there is this confusion. If we were to do a RACI chart, responsible, accountable, consulted, and informed, what is the RACI chart? Who is responsible for and accountable for data quality? Is it the producer, data engineer? Is it the consumer? What are your thoughts on that?
So I think that fundamentally the RACI is almost everyone. Almost everyone who is a stakeholder of data at the company has a part to play. I think that ultimately the data producer must be the owner of data quality in the same way that a software engineer building features must be the owner of code quality. Like we would never expect to say that a product manager or even worse, an in customer of some application is responsible or is an owner of the quality of that application. Fundamentally, it has to lie on the shoulders of the engineer who is building it. However, I do think that there is a responsibility of the data consumer and the data engineer to help the producer understand, what is the quality that they should, what are the quality checks and constraints that they should implement. In the same way that a product manager has to very clearly define the requirements for a set of features, its failure states, the UX, the UI. I think that data product managers, quote unquote, which doesn't have to be the official title. It could be a BI engineer, it could be a data engineer, it could be a data scientist. Really, it's anyone who understands the expectations of the data very, very well. It's their job to communicate that as accurately and in a semantically valid way upstream. Finally, I think that there is a responsibility on the non-technical consumer to communicate changes to the business to their more technical stakeholders. So, for example, at Convoy, at times we might have new types of shipments that pop in and out of existence based on whatever our sales and marketing team decides is going to be most valuable that quarter. It is the responsibility of those business stakeholders to communicate by ideally updating a contract that there's a new expectation, there's a new class of shipment type that needs to exist. Here are the qualities of that class. Here's when we expect to see it, and so forth. And then it is the responsibility of the data developers to frame that in a way that the upstream engineers can understand. And it's the responsibility of the engineers to actually implement and monitor that constraint.
This is so interesting. I am literally fascinated by this discussion. There is so much more I would love to ask you. We will save it for another time and another conference because we are reaching the end of our time. But any last words on what do you think about data products?
I think data products are the future. One of the interesting things about data products is that to me, all software, all a product is software for a purpose with a customer. And what we need to distinguish is what is a data product that's still in its MVP stage, and what is a data product that is actually production grade. It is ready to be consumed by that customer. Um, in my opinion, the data world, it needs to be split into two clear halves: a prototyping environment where people can build out MVP versions of products, and a production grade environment that is backed by contracts and observability and high quality engineering pipelines. And those data products have sort of everything that you would expect from any other software engineering product: clear ownership, clear management, and so on and so forth.
Very nice. Extremely well put. Thank you so much. Thanks, viewers, for tuning in, and we will see you at the next session. Take care. Bye.